Hello, Math 2. This is Mrs. Bricky, and this video is for Unit 6, Lesson 3. We're going to be talking about arc length and area of sectors. We're actually going to start with area. So you should be familiar with the formula for the area of a circle. Area of a circle is pi r squared. So we're going to find the area of these two circles just to warm us up. This first circle, the radius is 5. So the area is pi times 5 squared. And we'd like to just leave our answer in terms of pi and not turn it into a decimal answer. So if that's the case, you can usually just do it in your head and not use your calculator, but you can use your calculator if you need to. So pi times 5 squared would just be 25 pi. For this second circle, the diameter is 16, so we need radius for the area formula, so the radius of this circle would just be half of the diameter, so the radius is 8. So the area of the second circle would be pi times 8 squared, which is 64 pi. So we can also use these formulas to figure out the diameter or radius of a circle if you're given the area. So the first circle we're going to find the radius of has an area of 12 pi, and the second circle has an area of 12. So in both of these cases, what we're given is the area. So 12 pi, the area 12 pi is equal to pi times the radius squared. And so we can, we want to solve for r here. So our first step, we're going to divide both sides of our equation by pi, and the pi is going to cancel out. That's just the same as dividing by 3 or dividing by anything else. We can divide by pi, and that leaves us with a 12 is equal to r squared. And we need to take the square root to get our answer. So we're going to apply the square root to both sides of the equation. Now, normally when we do that, we put a plus or minus symbol. In the case of a circle and finding the radius, though, we know we're going to have a positive answer. We're going to have a positive radius. So we don't need the minus symbol. We'll just have a positive square root here. Square root of 12 is 2 root 3. And that's our radius. Now that one, we're going to leave that in radical form. So a circle whose area is 12 pi has a radius of 2 root 3. Well, circle K has an area of 12, not 12 pi, but just 12. So 12 is the area in our equation. So 12 is equal to pi r squared. So we still want to divide by pi, but this time when we divide by pi, we don't have a pi on the left to cancel. So I'm going to actually type 12 divided by pi into my calculator and get the decimal answer. So this one we are going to go into decimals. 3.8197 is equal to r squared. So now we're ready to take the square root. And again, normally we would want to use a plus or minus symbol, but because we're talking about a radius, we know it's going to have a positive length. So we're doing the square root of 3.8179. And that is 1.95. And I'm just rounding that to the nearest hundredth. So this circle with an area of 12 has a radius of 1.95. All right, so what if we only have a portion of the circle? We want to calculate the area of this semicircle and the area of this quarter circle. Well, the area equation we can still use here. This first circle has a diameter of 18, so that means it has a radius of 9. So if we had a whole circle, it would be pi times 9 squared, but we only have half of a circle. So it's going to be 1/2 of pi times 9 squared because we only have half. So let's calculate that. 1/2 times pi times 9 squared is, and I'm going to go ahead and leave my answer in terms of pi, 81 pi over 2. If you wanted the decimal approximation of that, that's approximately 127.23. So either of those answers would be okay. For this quarter circle, that's 1/4 of a circle. So it's going to be 1/4 of pi times 7, the radius squared. So if we get that exact value, that's going to be 49 pi over 7. Oh, sorry, 49 pi over 4. And if we go into the decimals, that would be approximately 38.48. A lot of times when we're doing area, we'll go into the decimal. Okay, so a sector is part of a circle that's enclosed by 2 radii and their intercepted arc, kind of like a slice of pie. So those 2 areas we just calculated really are areas of sectors. But a sector doesn't have to be half or a fourth. It can really have any central angle. So the equation for the area of a sector is really just based on the area equation for a circle. So you can see in my formula, we have that pi r squared for the area of a circle. And then this part of it is just essentially what fraction of the circle do you have? So if you have a 150-degree central angle, this would be a 150 over 360. If we had half of the circle, that would be 180 over 360. So it's just a way of finding out what fraction of the circle you have. So we'll just do the central angle or the arc measure divided by 360 and then multiply it by the area of a circle, pi r squared. So for this circle, we're trying to find the area of a sector. So we're talking about the area of this slice right here. So the central angle and the arc are 150 degrees. So 150 divided by 360, and we're multiplying it by pi and then radius squared. So the radius of the circle is 3. So 150 divided by 360 times pi times 3 squared. So the exact answer here would be 15 pi over 4, or that would be approximately 11.78. In this example, we're trying to find the area of that shaded sector that is shown in yellow. We're going to have to do a little bit of work. It does give us the radius is 2.4. So we do know the radius of the circle, but we don't directly know the angle. It's not given to us. We've got some markings to help us. So we've got this 126-degree angle right here. Well, that angle is vertical from this angle. That means that this angle from C all the way over to D is 126. And we've got some markings that say that it's broken up into 2 equal parts. So if we do 126 divided by 2, we're going to find that angle. And 126 divided by 2 is 63 degrees. So we've got a 63-degree central angle. So remember, our area of a sector formula is angle over 360 times pi r squared. So for this circle, that's going to be 63 over 360 multiplied by pi multiplied by 2.4 squared. Let's go into a decimal here. So that gives us 3.17. So that's the area. That would be centimeters squared. It's the area of that yellow sector. Okay, so this one says if we have a circle with a radius of 7. If that circle has a sector with an area of 27.8, what is the measure of the central angle? So our equation looks like this. So we know the radius is 7, and we don't know the angle theta, and we know that the area is 27.8. So we've substituted 27.8 for our area, and we've substituted 7 for the radius. We want to solve for theta. So the first thing that we want to do is we've got a denominator of 360. We want to multiply both sides of our equation by 360 in order to clear that denominator. So on the left, I have 360 multiplied by 27.8, and that is 10,008. So now we have a theta, a pi, and a 7 squared. So we want the theta by itself, so we can divide by the pi and the 7 squared. Just make sure you put it in your calculator in the fraction form like this. So I just want to show you a couple of ways that it's okay in your calculator and one way that it's not okay. So if you want, so this is our answer that we need our calculator to process. If you type it in exactly like that, it's okay. Using the fraction button, that would be fine. Or if you want to type it in using division, you can, but you need to put a grouping around the pi times 7 squared. Both of those are fine. If you type it in like this, that's going to give you the wrong answer. The calculator is not going to process it the way you want it to. It's going to divide by pi and then times it by 7. So just be careful how you type it into your calculator. So let me just divide that in my calculator. So I got 65.01. This says round your answer to the nearest degree. So theta equals 65 degrees. Okay, that's a challenging problem. If clearing the denominator in that first step is a good strategy. All right, so that was all about area. So we have two purposes today: to talk about the area of a sector, which we've just completed, and then our second purpose is to talk about something called arc length. Arc length is related to circumference. So circumference is the perimeter of the circle. So we're going to practice the circumference formula a little bit and then talk about arc length. So the circumference formula for a circle is that the circumference is equal to 2 pi times the radius, or pi times the diameter. Those equations are equivalent to each other. So in this first example, we have a circle with a radius of 5. So the circumference would be 2 pi times 5, and that's 10 pi. In our second circle, we have the diameter, so it'll just be pi multiplied by the diameter, and usually we write that with the 16 in front of the pi. And I left both of those answers in terms of pi. We could find the decimal equivalent if we needed it, but leaving it in terms of pi is great. We could also use these formulas to figure out the radius when we're given the circumference. So the first circle, circle F, has a circumference of 14. So that's the C, the circumference. So 14 pi is equal to 2 pi r. Well, if I divide both sides of my equation by 2 pi, that leaves me with r on the left, and 14 pi divided by 2 pi is 7. So this first circle has a radius of 7. The second circle has the circumference of 14, not 14 pi, but 14. So that's our C value. So 14 equals 2 pi r. And in this case, we also need to divide by 2 pi. Again, be really careful dividing with something like 2 pi. If you type in as a fraction 14 divided by 2 pi, that's fine. If you use the division button, you need to group the 2 pi like this. It would not be good to type in this. The calculator will not calculate it correctly. So make sure you either use parentheses or the fraction button. So in this case, the circumference, or sorry, the radius is 2.23. Okay, what if we only have a portion of the circle? Well, this is a semicircle, so that's half of the circle. So the arc shown in green would be half of the circle's circumference. So that would be 1/2 2 pi times the radius, or 1/2 pi times the diameter. The radius here is 9. So this would be 9 pi. So it's 1/2 of the circumference. For this one, we want to calculate the perimeter of the quarter circle. So we have two sides that have a length of 7, and then we need to figure out this curved side. Well, that's a quarter circle, so that's 1/4 of the circumference. And so this would just give us the arc part of it, the curved part. And then we would need to add 7 and add 7 to get the whole perimeter. So for this one, let's see, let me type this in. 1/4 of 2 pi times 7 plus 7 plus 7. And the calculator went straight to decimals if I typed it in that way. So that is 24.9955. So I'm just going to say 25. If I kept it more exact, 7 pi over 2 plus 14 is about as much as I could do. And those two are equivalent, roughly equivalent. I rounded the 25 a little bit. Okay, so arc length is a lot related to what we were doing here. It's where we only have a fraction of the circle. We don't have, the entire circle or even half of the circle. We just have some portion. Arc length is the distance or the span of an arc. We're definitely measuring length here, so it's not measured in degrees. This arc that I have shown in green right here, it has an arc measure of 60 degrees. We talked about arc measures before. It has a length of 8.37 centimeters. So if you have two circles that are different sizes, they might have an arc that has the same arc measure. Maybe we have an arc on each that's a 90-degree arc. So those arcs have the same measure, but they definitely don't have the same length. The second one is definitely much longer than the first one. So to calculate arc length, the formula is a lot like the formula for calculating area of a sector. We have this fraction of the circle. And at this time, we're multiplying it by the circumference. So for my diagram right here, we're trying to calculate the length of the arc from A to B. So we want to know how long this is. We have a circle with a radius of 7. So we're going to put the 7 here in the formula. And we have a central angle of 55 degrees. So the arc length is 55 divided by 360 multiplied by 2 pi times 7. If we keep that exact, it's 77 pi over 36. If we get that as a decimal, that's 6.72. And that would be centimeters. All right, so we've got a diagram. It says circle C has a diameter of 10. Can we find the length of the curve, length of the arc, from A to D. So we're looking for this arc length. So we've got a diameter here. So that means angle C, or the angle right here at C, plus 75 has to give us 180. So this angle is 105. And the diameter is 10. That means the radius is 5. So the arc length, we usually use the letter S for arc length, but it's okay if you don't use S. You can just calculate the arc length. That would be 105 divided by 360. That's the portion of the circle, multiplied by 2 pi times by 5. I'm having a hard time punching my calculator buttons. All right, so that would be 35 pi over 12. Or in decimals, that would be 9.16. And that gives us the arc length from D to A. Okay, so now we've got circle F, the arc length ED. So we know that this length is 23.9 inches. And our question is, what is the radius of the circle? Well, we have an angle that's 74 degrees right here, or sorry, 76 degrees, and that angle is vertical to this angle, so this one is also 76 degrees. So our arc length formula tells us that the arc length is theta over 360 multiplied by 2 pi times r. So we know the arc length is 23.9. And we know the angle is 76. The only thing we don't know is the radius, so we can certainly solve for radius. I'm going to go ahead and multiply both sides of the equation by 360 to clear the denominator. So on the left, we have 360 multiplied by 23.9. So that's 8,604. And over here, I have 76 times 2 pi times r. So we can divide by all of those coefficients there all at once if we want to. Divide by 76 times 2 pi. Again, just be careful how you punch it in your calculator and use that fraction button to avoid errors. And so when I did that calculation, I got that the radius is 18.02. Okay, so we did arc length and area of a sector. Those equations, I hope you can see the similarities. For arc length, we just use the circumference, and for area of sector, we use the area formula for a circle. All right, you are absolutely starving and you get one slice of pizza. You either can choose a slice from a 6-slice pizza with a diameter of 16. That would be a radius of 8. Or you can choose a slice from a 10-slice pizza with a diameter of 24. That would be a radius of 12. You're starving, so you want the most pizza you can get. We want to calculate the area of each slice to help you decide which one to take. So we need to know the angles here. So if we're thinking about this circle, that's a 360 degrees circle that's divided into 6 parts. So each of them is 60 degrees. Well, the other pizza is 360 degrees. That's divided into 10 slices. So each of the slices is 36 degrees arc measure. So applying our area formula for the first pizza, the area of one slice is 60 over 360, or you could use the fraction 1/6, times pi times 8 squared. And since we're doing a comparison here, I'm going to go into decimals. So that one is 33.5. And from the second pizza, the angle is 36 degrees. And the radius is 12. So that's 45.2. So definitely, if you're starving, you should pick the pizza slice from the larger pizza. Okay, same question, sort of. Same pizzas, I guess. So we've got 60 degrees and we've got 36 degrees. We have a radius of 8 and we have a radius of 12. You aren't starving, and your goal in life is to consume as much pizza crust as possible. You get one slice of pizza, either from the 16-inch pizza or from the 24-inch pizza. Calculate the crust length of each. So the crust from the first pizza. The crust from the first pizza, if we're calculating that one, that's going to be 60 over 360. Crust is like circumference, so we're going to do 2 pi times 8. That's 8.4 inches of crust. And for the second pizza, that is 36 over 360. And the radius of this pizza is 12. And so we get a crust length of 7.5 inches. So if your goal is to eat as much crust as possible, you would actually want to pick a slice from the smaller pizza. That will give you a little bit more crust. Okay, that's it for this video. If you have any questions, talk to your math teacher. Thank you so much.